Subscribe and click the notification bell to stay updated with the latest videos from School of Technology, Management and Engineering NMIMS in
A very warm afternoon to one and all present here. Today, I, Akshat Jain, on behalf of NMIMS School of Technology, Management and Engineering, Indore, takes immense pleasure in welcoming all of you back to the second session of this wonderful day. Before we move further with a very inquisitive topic, I would like to inform you all that a feedback form will be floated in the chat box. So please fill the necessary details correctly, as attendance will be provided on the basis of the submission of feedback forms only. The first session was based on data utilization in IoT. This session will focus on connecting boards and sensors to a cloud IoT platform for control and command. To throw some more light on this, we have with us Dr. Ramachandra Satyadev Tiwari. Dr. Tiwari has a diploma in MSc Physics and holds PhD in Educational Communication, Computer Science. He has 44 years of experience in the field of computer science. He has worked as a scientist in MERI for 20 years, where he carried out research on satellite image processing, computer graphics, and mathematical modeling. He is currently the technical director at Cognifront Nashik. He has had more than 10 research papers published in national and international journals and conferences. He was awarded National Science Talent Scholar in 1971 and Yashokirti Award given by CSI Nashik in 2002. He also mentors and directs startups. We feel privileged to have you today with us, sir. I now request sir to share his valuable inputs to the audience.
Thank you, Akshat, and all the other members and participants. I am very glad to be in this video conferencing and sharing my experience of IoT with all of you. We will switch on the video when our hands-on session starts. So right now, I am going to highlight the introduction of what we are going to do today. So friends, let us begin. I am sharing my screen. Am I audible and is the screen visible to everybody?
Yes, sir. The screen is visible.
Okay, thank you. Not able to, okay. Let me do small adjustment and then we'll continue. Okay. I am Dr. Tiwari. On today's agenda, we are going to discuss IoT architecture of ESP32 microcontroller board, IoT Cloud Platform, and the IoT Cloud open source platform, namely ThinkSpeak Cloud Platform. And then we will see how to connect various devices and boards to ThinkSpeak. And as on hands-on activities, today we will see how to operate panic switch using ThinkSpeak. We will also try to control some appliances, that is home automation, and we will try to give the demonstration of patient monitoring in hospitals. We will also have hands-on LDR sensor and change of light, then parking system, and then we will also have a demonstration of voice-operated devices using ThinkSpeak. And then ThinkSpeak is also will be used to send emails and do some tweets. So friends, with these exciting hands-on activities, let us proceed. Here we see 4 industrial revolutions. You already know, so I won't talk much about that. But the current industrial revolution, that is Industry 4.0, is based on IoT, and that is why we call this as IIoT. So in brief, we will see that IoT devices are capable of measuring physical quantity, monitoring them, controlling them, then reporting, storing, and doing some exchange of data. Okay. Friends, here we have very simple example of application of IoT, namely ATM machine. Everybody has seen this ATM machine. If we have a bank account, let us say I have a bank account in Nashik, and then I go to Hyderabad and withdraw rupees 500 from the ATM machine, then those 500 rupees will get deducted from my bank account in Nashik. Now this happens automatically only because ATM machine is connected to the internet, and of course via internet it is connected to the computer in my bank. Another interesting example is of Android phone. All of us know that if you have a net pack or a data pack, then you can run WhatsApp, Facebook, Instagram, Twitter, and many more applications through which you get connected with your friends. And you are able to share information or any kind of data, maybe audio, video, animation or so, only because you are connected to the internet. So friends, there is a power of connecting various devices to the internet. Now, short introduction to sensors. Now, sensor is nothing but a device which measures physical quantities like temperature, humidity, light, movement, and many more physical quantities. Some examples of sensors are visible on the screen. We have on the left temperature and humidity sensor. In the middle, we have a pressure sensor, and this is the light sensor. And then there are number of sensors or types of sensors available in the market. We have compass sensor, flow sensor, humidity sensor, level sensor, motion sensor, and so on. So hundreds of sensors are available in the market, and these sensors are useful for a variety of applications. Now, depending on your application, you have to select one of them, one or more of them. Then you also require actuators. Actuators are also available in a lot of variety. Here, as an example, we have lamp, we have buzzer, servo motor, stepper motor, DC motor, and so on. And of course, for connecting any device to the internet, okay. I think there was an issue that slide was not moving further. I think now you can see. I mean, is the slide moving forward now? Okay. Gaurav, am I audible? Hello, am I audible?
Yes, sir, you're very much
okay,
audible.
Fine. And the slides are moving, isn't it?
Yes, sir.
In the mean, there were some slides, I mean, stuck up. Now they are moving. Okay, fine. So our next important thing is that of Arduino microcontroller. So Arduino microcontroller is a low controller board. It costs around 400 to 500 rupees. And then we have much more powerful microcontroller board called Raspberry Pi. We are talking about these two boards only because they are open source. That is, if your product or a device using these two microcontrollers, then no necessity of taking permission from anybody. They are open source. Raspberry Pi is useful when you have a lot of data. For example, if you have a camera and images or video are updated, then Raspberry Pi is the must. Whereas when you have simple sensors and you want to send data to the cloud, then Arduino is enough. And now let us see what kind of assets or say objects or maybe devices connected to the internet. In our day-to-day life, we see not many devices. For example, we have ATM machine, it could be a smartphone, it could be a computer, it could be a robot, it could be a drone, driverless car, petrol pump, machinery in say factories, refrigerator, then home, smart home, TV are connected to the internet. Now, let us switch over to another important topic after sensor, actuator, and microcontroller, that is a cloud, which we in general call the cloud computing. So what is a cloud? Cloud is nothing but a storage where thousands of servers are placed. That location is called a data center. And when such servers are available in the data center, and data center is connected to the internet, then naturally we have the power. That is, if we connect our smartphone or any other device to the internet, then it also gets connected to the data center, that is to the cloud. Having to the cloud makes the connectivity available everywhere. So we say that it is ubiquitous. Then connection is very convenient. You don't have to, install any application, directly write the URL in your browser and you are connected to the cloud. And moreover, it provides on-demand network access to shared pool of computing and resources like servers, storage, applications, and services. The resources can be rapidly provisioned and released with minimal management effort. The main goal of cloud computing is to provide computing services with high scalability and availability. Now, what you see on the screen is a 4 layers of cloud. There are 4 layers: hardware layer, infrastructure layer, platform layer, and application layer. In between hardware layer and software, this is a platform layer, and also infrastructure layer and hardware layer, we have a network engineer or administrators working. And between platform layer and application layer, we have software developers working. And at the top level, the end user like us are working. Working in the sense, we use the top layer of cloud. Software developers use platform layer, and network and other administrators use infrastructure layer and hardware layer. And these 3 categories of users and the corresponding part of the cloud that they use is called as infrastructure as a service, platform as a service, and software as a service, SaaS, PaaS, and IaaS. In industrial automation, there are again 5 layers: level 0, level 1, level 2, level 3, level 4. Starting with, let us say, sensors and signal Then in industry, we find PLC, Programmable Logic Controller, SCADA, then manufacturing operations management, and business planning logistics. But today, all this architecture is changed. And now we are using the IoT-driven architecture for industrial automation. Here we realize perception layer, network layer, processing layer, and application layer. The processing layer is concerned with the cloud. What we call as a cloud is the processing layer. And after that comes the application layer, where we have variety of applications which you have studied during last few days. So this is the power of cloud and IoT. Now, before we continue and have hands-on say activities, let us try to understand what kind of devices we can connect to the internet or to the cloud. Here we will be having hands-on with a very interesting and latest microcontroller called as ESP32. This ESP32 has 30 pins, so it is quite powerful, and it has inbuilt Bluetooth stack as well as Wi-Fi stack. So if we want to use Bluetooth and Wi-Fi, we can directly use with this microcontroller board, that is the power. On the contrary, if we use Arduino, then we have to have additional connectivity devices like ESP8266 or so to provide the connectivity. Whereas with this ESP32 board, we can directly use Bluetooth and Wi-Fi. ESP32 is very low cost. It costs around 500 to 600 rupees. In fact, it is a total system on chip, SoC type of device. It is a modified or higher version of earlier ESP8266 microcontroller board. This board can be programmed using variety of programming languages like Lua, MicroPython, C, and C++. And of course, a very popular Arduino's IDE, that is Integrated Development Environment, can be used for ESP32. So in this way, using ESP32 and Arduino IDE, no extra learning is required. So all the friends, all professors and friends and faculty members who are familiar with Arduino can easily switch over to ESP32. So let us see how to connect microcontroller board to the cloud or a server. There are many ways of connecting device to the cloud. Like you can use HTTP protocol, you can use MQTT protocol, and you can also use the GSM board. So variety of methods are there. Socket also is there by which you can connect device to the server. But in today's session, we are going to study a very important and easy to understand protocol called as HTTP protocol. And you will be surprised to know that ESP32 microcontroller has a built-in full HTTP stack. That is, we do not require any other hardware to connect ESP32 board to the cloud or a server. Everything is available inside the board. So we will be using HTTP protocol in which we will consider client and server model. That is, our ESP32 board will work as a client and server or a cloud will work as a server. When ESP32 board sends the request, server will do some processing, get the required data, and send that information back to the ESP32 as a part of response. So we have request and response. As an example, let us try to understand how ESP32 is connected to the server via internet. So at one side, we have some sensor connected to the ESP32, and we also have an actuator, like let us say a DC motor, or could be a fan. So actuator could be a fan and sensor could be a temperature sensor. So ESP32 will pick up the sensor data and then try to send it to the cloud. Now, in order to send data to the cloud, we require Wi-Fi router. Now, many people have a router at home or maybe available in the office. So first, our ESP32 gets connected to the router, and from router, it is connected to the server or a cloud via internet. And that is why you have to purchase a subscription for Wi-Fi service. And in the cloud, when temperature data goes and it is processed, and if the temperature, let us say, goes above 30 degrees Celsius, server may respond some command, and according to that command, the fan may get actuated in your home. So in this way, we can have a very simple automation in our home. Connect the temperature sensor to the cloud and also connect the actuator to the cloud via ESP32 and write a small program in the server to analyze the temperature data. And as soon as the temperature goes above 30 degrees, send the command to switch on the fan. So command will come to the ESP32, and then ESP32 will actually start the fan. Now, ESP32 is a dual core powerful microcontroller, and it has Wi-Fi connectivity at 2.4 gigahertz, Bluetooth, and also BLE is also available. It is a 32-bit microcontroller, and frequency is as high as 240 megahertz. And it has a RAM of 512 KB, and it has 30 or 36 pins on the board, depending on the model you select. 30-pin board is quite popular, and we'll be using that. It also has internal memory of 512 KB, and it has a flash memory of 4 MB. Now, let us try to understand some Gpio pins of ESP32. It has digital pins and it has analog pins. Let us say when we have a digital sensor like a button, when you press a button, value 1 goes. When you release a button, value 0 goes. So that forms the digital sensor. Similarly, ESP32 has digital output pins. So through ESP32 board, we can switch on the lamp and switch off the lamp. That means there is a digital output, low and high. Similarly, microcontroller has capability of measuring or taking analog input. So if we have an analog sensor like let us say a microphone, or could be a temperature sensor, analog temperature sensor, then that can be picked up by ESP32 board with a different pin. So as there are 30 pins, every pin is capable of working as input pin or an output pin or whatever, I mean, analog or digital. Now, these 30 pins are multifunctional. In the sense, same pin can be configured through writing a program as input pin or output pin, or as a digital input pin or analog input pin, or analog output pin or digital output pin. And also, I mean, there are other functions as well, like pulse width modulation. So these details cannot be covered just in one lecture, but I'm just telling you that this microcontroller has the capability of defining the mode of or a function of the pin. Now the pins D5, D18, D19, D21, 22, and 23, along with RX2 and TX2, which are pins 16 and 17, can be used as digital input, digital output, and analog output, but not as analog input. Similarly, pins D34, D35, and Gpio 36 and 39 can only be used as digital input and analog input only, not as output. Okay. Now, one important thing to note, that ESP32 works on 3.3 volt, whereas Arduino works on 5 volt. And many sensors in the market work on 5 volt. And therefore, we have to take care that whenever we connect any 5 volt sensor, for example, ultrasonic sensor works on 5 volt, then you have to forcibly reduce the voltage level to 3.3. Otherwise, that 5 volt level will damage our ESP32. So logic level conversion is required when we connect any 5 volt sensor to 3.3 volt ESP32 board. Here you have a overview of various pins available on ESP32. Then let us come to another important point, that is how to give the power to ESP32. There are various methods. One method is connect the ESP32 board to the microcontroller, so to the computer, because you will be programming ESP32 using laptop or your desktop. So in that case, you can connect the wire like your mobile charger cable, which is a data cable. So use the same cable which is used for mobile charging. So you can take that data cable and connect your ESP32 board to your computer. And along with the data, power also comes from the laptop to the microcontroller board. So your microcontroller can derive power from computer. Another way is to use a power adapter like your mobile charger. So you can use the mobile charger to provide the power to the ESP32 board. Or you can also use the power bank. And the last way is to get any 5 volt regulated power supply from outside and connect it to the VIN pin. So here you can see that this ESP32 board is connected to the laptop on the left via this mobile charging phone. So this wire is connected to the laptop. Here, power is derived from power bank. Here, power is provided through the adapter, which we use for our mobile charging. And here, our power supply connected to the VIN pin of ESP32. So you can charge or you can provide power to your ESP32 board in any one way. But you have to be very careful that you should use only one supply at a time. Don't try to connect 2-3 supplies to ES32, otherwise it will get damaged. For example, if you have already a connection of your ESP32 with your laptop, then don't try to give power from outside to behind pin. Otherwise, two power supplies together will damage the ESP32 board. Now, very simple observation. On this ESP32 board, there is two light emitting diodes. The which is shown on the screen glows when you apply the power. Then there is another light emitting diode, which is blue in color, is connected to the pin number 2. And whenever you write a program to provide high voltage to D2, this lamp will glow. This lamp is mainly used for debugging the ESP32 board or debugging our own program. Now we come to another interesting part before we start our hands-on activity. Here we have some introduction to the IoT platform. So far, we have discussed IoT, cloud platform, and here we are trying to put two things together, namely IoT and cloud. So that is called as IoT platform or IoT cloud platform. Even it is called as IoT cloud platform. Now, what is this platform? That is a combination of IoT and cloud along with some software is called as a platform. So what is the advantage of using IoT cloud platform? It mainly serves as a mediator between world of physical objects and the world of actionable insights. That is real life objects and software programs, and of course a variety of graphics together provide us the ability to develop a variety of applications. So combining numerous tools and functionalities, IoT platform enables us to build unique hardware and software products. And this is possible because we are able to, that is, platform makes us able to collect, store, analyze, and manage variety of data generated by various devices. So you can design any product very easily with the help of IoT and cloud put together. We have large number of IoT cloud platforms available in the market. Amazon Web Services is a very popular web platform. Then we have IBM Watson, we have Microsoft Azure, we have Google Cloud, we have Oracle Integrated Cloud, then we have SAP Cloud, Cisco Jasper, and ThingsWorks is also very popular in the manufacturing industry, PTC ThinkWorks. Then we have Salesforce IoT, Xively, Carriots, and of course the car IoT platform is also very popular. So all these platforms are used by many industries and businesses, but most of them are proprietary and you have to pay for that. And their source code is not available. But now we are going to use ThinkSpeak, a very good open source platform. It is open source. It is full source code is available, and moreover, you can use it free of cost with certain limitation. We will see the limitation, but ThinkSpeak is a open source IoT cloud platform. Being open source, anybody can use it. ThinkSpeak is used for developing IoT applications. Particularly, we can collect the data from sensor, we can store, we can analyze, we can visualize, and we can also control. We can take some action on the given application. For example, there could be a DC motor, there could be a fan, there could be a boiler, any kind of actuator we can activate, and moreover, we can send the alerts and let us say in the form of email, in the form of SMS, audio, or whatever. So all these things can be done very easily with the open source IoT platform called ThingSpeak. Here, a very simple example, there is a temperature sensor, and ESP32 microcontroller will read the DHT sensor and send the temperature data to the cloud. Cloud means our ThingSpeak server. And then in ThingSpeak, we have the software through which we can visualize the data. For example, here you can see that temperature is shown on the gauge. So such visualization gauges and other widgets are available in ThingSpeak, for which you do not have to write any program. Without any programming, you can start using this. Now, we also have a return path. Upper ESP32 board is actually reading the temperature, sending that temperature data to the ThingSpeak, and inside ThingSpeak we have given a command through which the as and when temperature goes above certain threshold, a command is sent to another ESP32 which will actually blow on the say siren, which is a buzzer. So in industry, whenever something happens, temperature goes above certain threshold, a siren blows so people can run away and save their lives. At the same time, there is a widget which is showing the real-time temperature value. Friends, we can connect ESP32 to the ThingSpeak, but we can also connect any mobile phone. Your smartphone, Android phone can also be connected to the ThingSpeak. And then we have a power. On the mobile phone, we can have buttons. And if we press the button, that will be detected by the ThingSpeak, and ThingSpeak will send the command and the buzzer will blow. And in place of buzzer, you can have any actuator, like it could be a motor, it could be a wiper, it could be a boiler, it could be a heater, any kind of activity you can perform. Moreover, it is also possible to see any kind of data that is available in the ThingSpeak on the Android phone. So data in the server can also be monitored, can be visualized, and also you can send commands from your Android phone to the other end. It's interesting to know that ThingSpeak is placed in the server, that is, it is in the cloud, and therefore, let us say you are in Delhi, somebody is in the Delhi and he is actually pushing a button on the mobile phone, then a buzzer in Nashik will actually blow. Because Android phone and ESP32 are connected to the internet, that is IoT. And being connected to the internet, the whole world gets connected. For example, if you are traveling in France and you are on tour to Eiffel Tower, right from there you can press a button on the mobile phone and play on the buzzer right in India. That's the power. So getting devices connected to the internet gives us the ability to fetch the data from any number of sensors spread throughout the world, and moreover, from one location or from multiple locations, you can send the commands to activate any device anywhere in the world. from billions of devices, store it in the big data and do analysis, and then we develop the insight. For example, if we are collecting data about air quality throughout the country, then we can instantly get the information about the most polluted city and the least polluted city, and we can grade the cities accordingly. So all that is possible only when we have data from large number of such devices spread in the country. So that's the power. Now, what is ThinkSpeak? So in ThinkSpeak, I hope we will have a small change, and then I will again come back. First, we will try to get one demo, and then again come back and continue further information about the ThinkSpeak. So now, Gaurav sir, can you hear me?
Yes, sir, you are audible.
Hello.
Hello. Yes, sir, you are audible. Sir.
So I would request you to make the another user in the video called as Cognifront as a presenter. So
okay, sir. Just a minute, I will do that.
Oh.
Hello.
सब बना दिया co-host.
Gaurav.
Yes, sir. Yes, sir. Cognifront has made a co-host.
नहीं, उसको थोड़ा चेंज करो. Make it Aditi Kulkarni. One more.
Okay. Aditi Kulkarni
is there. Who is
okay.
Aditi Kulkarni.
Okay, just a minute. Done, sir. Hello. Am I audible, sir? Hello. Sir, you can stop the screen share so that everyone can see it in the on the big screen.
what you see now is Mr. Swaraj, and I have fitted a belt on him, and that belt contains ESP32 microcontroller. And also there is a accelerometer device available on the board. Now what we do, we have connected this ESP32 board to the router at home, and then it is get connected to the ThinkSpeak. So this is a ThinkSpeak. Okay, so this is a ThinkSpeak cloud. Okay, this is status of the. You can see that right now Swaraj is standing. So he is standing, and therefore ThinkSpeak cloud, there is a widget. This widget is red in color. Now I will ask Mr. Swaraj to lay on the cot. So he will be sleeping on the sofa, and after 15 seconds, this lamp should go off. Sit down. Now sleep down. Sleep. Now he is sleeping on the sofa. We will see that after 15 seconds or so, the lamp should go off. Yes. So you can see that lamp has gone off. So let us try to see. He is sleeping. Just stand up. So he's just stand up. Now he is standing, and here again the lamp should go on after a few seconds. Yes, you can see again lamp has gone high. The delay is because we are using free service. If we make the payment, then we will get this action in real time. So friends, this is how we can use ESP32 board to carry out variety of applications. So let us continue with the remaining part of ThinkSpeak, and then we will come back for demonstration. Gaurav sir, please switch over the control to RS Tiwari.
Okay, sir.
Dr. R.S. Tiwari is the co-host now.
Yes, thank you. Okay, thank you. So friends, we just saw a demonstration where a patient was asked to say sleep on a bed, but the patient, being very naughty, did not listen to the doctor and got up and started walking here and there. Now this status, whether the patient is sleeping or standing, can be detected using accelerometer and ESP32 microcontroller board. So by connecting devices to the ThinkSpeak, we can design and develop variety of applications. So before we go and talk about the connectivity and the source code, let us try to understand the concept of channel and field in ThinkSpeak. In ThinkSpeak, we have a concept called channel and field, F-I-E-L-D, field. In a free version, we can create 4 channels. And if you pay, you can create more channels. Now, what is a channel? Channel is nothing but a place where we put or we store our data. Now, within that one place or within one channel, we can place 8 different, which we call as fields. Like a table. In Excel, we have a table. Now, within one table or a spreadsheet, we can have number of columns. And we can have number of spreadsheet in Excel. Similarly, here in ThinkSpeak, when we have number of channels, but in free version, we can create 4 channels, and in one channel, we can have 8 fields. So in a free version, we can have total 8 into 4, that is 32 fields. Now, a channel can be thought of as one big device. And within that big device, there could be number of sensors. Like you have temperature sensor, you have pressure sensor, you have humidity, you have light, and you may have, let us say, moisture. So these 5 values of 5 sensors can be put in 5 different fields. And these 5 fields can be created within one channel. So that is the concept of channel and field. Now, another important thing, in order to protect the data, because you may have very important and sensitive data, so that needs to be protected. Otherwise, hacker will enter and destroy your sensor or make the changes in your data. And if the data is, let us say, related to healthcare, it could be very sensitive. So, in order to protect the data, API keys or a protection keys. So these API keys are generated when you create a channel on the ThinkSpeak. These API keys enable you to protect your data. So the API key that is generated for you can be used. Slide but okay. So these API keys.
चॅनल अँड फील्डचं कुठलंच दिसली नाही.
बरं ठीक, आता दिसते का बघा?
आता दिसतीये का? मी बघते सांगते.
So API keys enables protection. So what we do when we create a channel, and API key is generated by the ThinkSpeak. So we use that API key to provide code. Just a minute. Okay. Is it okay? So these API keys are used by users to their data. Other people or hacker cannot enter the device without having this API key. Then ThinkSpeak also provides us data visualization. So as part of visualization, variety of gadgets or widgets are available. Then there is a power of MATLAB so that we can plot charts and so on. Then ThinkSpeak also provides us the power of analysis and reacting on the data. So this is interesting example of ThinkSpeak, where data from soil moisture, temperature, then humidity, luminosity are collected by Arduino and sent to the ThinkSpeak cloud. And this data is visible on our end. And we can switch on the lamp, or we can blow buzzer, or we can start the motor in the agricultural field. A general view of ThinkSpeak is shown here. Let us say on the left-hand side, we have ESP32 and some sensor and actuators are connected to the local device. Then data of sensor is picked up by ESP32 and sent to the ThinkSpeak. And then analysis is done, and ThinkSpeak will actually send data to Android app. That is, app will read that data and show it on the Android phone. And through Android phone, we can press a button, send that data to ESP32 for actuators, and from ThinkSpeak it will go to the ESP32 and some actuator will work. The important features of ThinkSpeak are you can easily configure the devices either to send the data to ThinkSpeak or read the data from that. And you can use a variety of protocols like HTTP protocol, MQTT protocol, COAP protocol, and so on. And we can visualize the sensor data on our monitor. Then we can also aggregate the data on demand from third-party sources. We'll see what is aggregation shortly. Then we can use the power of MATLAB to make the sense of data. And then we can also run analytics automatically on scheduled events. Then we can also send the email or send data to the Twitter. Then we can prototype and build IoT systems without setting up server and developing web software. So without actually having our own server, we can easily develop the prototype of the application and test it. The only disadvantage of free ThinkSpeak is that you can send or read data from the cloud at an interval of only 15 seconds. So with the delay of 15 seconds, we can either send the data or get the data. And that is why in our earlier demonstration, when person was standing, the lamp went off after 15 seconds. And when the person was lying on the bed, lamp off again by under 15 seconds. So that delay is because of our pre-service. If we make the payment, then things will happen instantly. So I was talking about data aggregation, which is available in ThinkSpeak. It is nothing but gathering the data from variety of sources and summarizing it. This aggregation and also data analytics ability makes us derive insight in market research, in product research, in product positioning, customer reviews, sentiment analysis, or any kind of like a recommendation, any kind of activity related to business. Now, In the data analytics, we have 4 categories. The first data analytics is called as descriptive analysis. This descriptive analysis looks at the past and tells about the future, and also tells mainly about what has happened in the past. This is used while tracking key performance indicators like revenue, sales, leads, and more. After doing descriptive analysis, that is what happened in the past, we come to the so-called diagnostic analysis. It aims mainly to determine why something has happened. Once our descriptive analysis shows that something has happened, the diagnostic analysis can be done to figure out the reason. For example, one business month found that the leads increased in the month of October. That is, there were lot many inquiries in the month of October. Then, using diagnostic analysis, that businessman can find out how this lead increased only in the month of October, means what kind of marketing strategy was used so that leads were increased in the month of October. So this is how diagnostic analysis works. Then we come to another analytics part called as predictive analytics or predictive analysis. This predictive analysis predicts that what is likely to happen in the future. Descriptive analysis talks about what happened in the past, and predictive analysis talks about what will happen in the future. Trends are identified from the past data, and then they are used to predict the future. As an example, data from previous year can be used to predict the next year's revenue. And the last, prescriptive analysis. It combines the information found from the previous 3 types of data analysis and builds a plan for action for the organization. That is, having done earlier 3 types of analytics, now we can build a concrete plan about what to do in the business. So in this way, data analysis can be done very effectively using ThinkSpeak. So without writing much code in ThinkSpeak, you can do all such things. So we have already talked about the cloud. And why cloud? I think, again, we already discussed that cloud is required to centrally process huge amount of data coming from billions of devices connected throughout the world. Right now, it is more than 25 billion devices connected to the internet. And the huge amount of data is being streamed. So this streaming data has to be stored somewhere, and for that we use cloud. Now, in general, any IoT system that you will be building will require 4 layers. The first layer, sensors and actuator. Then you require some kind of connectivity, that is gateway and data acquisition system. And then you can do a lot of things in the cloud, but cloud is far away. And therefore, there are applications where you have to take the decision in split of a second. As an example, connected cars. So when cars are connected to the internet and the decision is to be made for applying the brake, then it is to be done in split of a second. Otherwise, that car will overrun some pedestrian. So in that case, we use so-called edge computing. So edge computing is the computing which is carried out very close to the devices which are placed in the field. So the edge computing will be placed directly inside the computer in the car. And of course, lastly, the cloud services. So in this way, for most of the IoT systems, you have to break down everything in these 4 layers. Now, how to connect your hardware to ThingSpeak? For this, we will actually go on the ThingSpeak say website and try to understand and do some activities. So I'm switching over my presentation to ThingSpeak. I'm not able to. I don't know why.
Dr. Tiwari, so you have made the co-host again.
There was some problem, but now it's okay.
Okay, sir. So are you going to start?
Yes, I'm going to start.
Okay, sure, sir.
I'm not okay. I'm not able to share my ThinkSpeak. I don't know why. Okay. Is the
So the screen is visible now.
ThinkSpeak channel is visible, isn't it? Okay.
Yes, sir, it's visible.
Okay, fine. So friends, what you have to do, you have to type thingspeak.com. So when you write thingspeak.com, you will be asked for signing in. So what you can do, you can use your account like Google email account, like Google email account, and get a password from the thingspeak.com and log in. So once you log in, what you see will be this screen. So this is the first screen that you get. Okay. Now here you have the options like private view, public view, channel setting, then sharing, API keys, and data import and export. For example, when I go to private key, and I have already created one channel and device. After this slide, we will be moving on to hands-on. So you will be creating this device or a channel on your own. First, let me give you some basic idea. So here, the channel that I have created has the identification number 1586382. This number has been given by ThinkSpeak. And the channel is private. The difference between private and public channel is that private channel is visible to the owner only, and public channel is visible to everybody. So in this channel, I have a view option. So when I click on view, private view, I get a private view of the channel. I have created 3 fields. So in field number 1, you can see there is some data. In field 2, there is no data. And then you can see that this channel was created at a location Nashik. So Google map shows the location. If you enter the information, I already entered that information. Now I will show you one real-time data entry which you will be doing yourself. One more concept, that in order to use this channel or a field and protect your data, you have some secret values. While writing data to the cloud, I have been given this key from ThinkSpeak. Similarly, when you create your own channel, you will get your key. And for reading information from the cloud, I have this key. Now, using these keys and the web browser, we are able to send the data directly to the cloud. For example, let us say, here we see that our last value is here. Now we will try to enter some new value. That can be done from here. Let us say, using, I'm trying to send this value. I'm not able to. Okay. So I'm. Is the screen visible? This new screen?
Yes, sir. The Chrome screen is visible.
Okay. Now I have entered one value from here, which should be now visible in our private view. Yes, now you can see the value 78, which I entered. Now this new point has come, you can see. I had entered 78. Now we will enter a small value. Let us say we enter 10. So let's go here and try to enter value 10. Now this value goes to ThinkSpeak from my browser. And again, I can switch over to ThinkSpeak and let us see whether that value is. Yes, now you can see this value 10 has come. So from 78, it has directly jumped to 10. So this is how data goes to the ThinkSpeak and it is made visible on the chart. So chart actually keeps on drawn for field 1. Similarly, we can have a chart for field 2, field 3, and so on. Now, from here, we will go to actual demonstration and hands-on. So, Gaurav sir, please switch over the control to I think to Cognifront.
Okay, sir. Wait a minute. Sir, done.
Sir, Cognifront is the co-host now.
Hello.
Hello.
Hello. Am I audible?
Yes, sir, you're audible.
Live
Hello. Am I audible now?
Yes, sir.
Please let me know if I am audible to you or not.
Yes, sir, you're audible.
Okay, fine.
Yes, sir, you are.
Okay. So good afternoon to all the entities present from all over India. I am Swaraj Tade, IoT developer and trainer from Cognifront Nashik. So after a very informative session based on IoT cloud platforms, let's look at some of the real-time demos we have for you on the occasion of today's session based on IoT. But before that, let's see some steps related to the ThinkSpeak, how to connect to or how to open your account on ThinkSpeak. Can you see the slide?
Yes, sir.
Okay. Now, I request everyone to open your browser and enter this URL www.thinkspeak.com.
Sir, can you please paste it in the chat box?
Yeah, sure. Now see the chat box. I have pasted the link.
Thank you, sir.
Yes. Now simultaneously, I request you all to follow the steps so that your account will be created in a right way. So first, we will visit this site, that is www.thinkspeak.com. Can you see this page on your browser?
Yes, sir.
Okay. Shall we move forward then?
Yeah, sure.
After that, click on Get Started for free. So using this, we will create our own account. And one more thing, it will take that while creating your account, you need your email account as well. So the verification related to the ThinkSpeak will come on your Gmail account. So I request you all to have your Gmail account turn on as well. I mean, signed in as well.
Okay, sir.
Can you see my screen? On the chat box, Honorable Miss Meeta Gandhi ma'am is saying that your screen is freezed.
So what slide are you on? Can you please confirm? You're on slide 14, right?
Yes, click on Get Started for free and click on account using email account.
Yes, sir. The screen.
So that is our current slide. So have you went through this, everyone? Get started for free. Shall we move forward if this step is done?
Yes, sir.
Fine. Now the next part, as Honorable Tiwari sir said, we need channels and fields in our ThinkSpeak. So our first part is to design our channel. So
excuse me, sir. Sorry.
Hello.
Sir,
am I audible?
Yes, sir. Excuse me, sir. Sir, I think the screen's frozen for half the people in the meeting. So can you please reshare?
Wait, let me reshare it again.
Sure, sir. Thank you.
Now, please let me know if the problem is resolved or not.
So can you please try changing the slide once? So we'll know for sure. Yes,
Okay.
sir. It's not frozen. It's working perfectly.
Okay. So shall we move forward then if the problem is resolved?
Yes, sir.
Okay. Now click on the new channel. I request everyone.
Sir, just wait a minute. I'm signing in. Sir.
Hello.
Yes,
Hello.
sir.
Okay.
Yes, sir.
Yeah, due to internet issues, it was disconnected. But now, is it visible to you all again?
Yes.
Yes, sir.
So after having this step, let's see what the channel is all about. So in ThinkSpeak, your channel is nothing but a database where you can store your own data. Okay, and on every channel, you can store data in 8 different fields. So suppose you are designing a system in which you have 8 different types of data or 8 different types of physical quantities coming from the environment, or eight sensors you have connected to your system. So at that time, if you want to store the data of those 8 sensors, so it will consume one channel. Okay, because ultimately on one channel we have 8 fields, which means 8 type of data we can store. Okay, so for free version, we have 4 channels under one account. So when we say we have one account, which means on the Gmail account, using your own Gmail account, you can create up to 4 channels only. Okay, so 4 into 8, so we have 32 fields for storing our data. Now you can get data into channel from a device, from a website, or from another ThinkSpeak channel. Okay, then you can visualize and transform it using ThinkSpeak apps. We have different visualization and the web and ThinkSpeak related apps are there. Now, after having this step, you must have this screen, right? You must have this screen. Now enter the name of the channel, enter some description related with the channel, and they have given the selectivity options so that you decide how many fields you want to access. Now here I have invoked only 2 fields. Okay, is this screen visible to you all?
So the PPT screen is visible.
It is not freezing, right?
No, so only the PPT screen is visible.
Sir, can you please share your whole screen, complete screen?
Wait. I think the PPT has been freezed, so that's why.
No, it is not freezed.
Okay, fine. So now, after following this step, you must have got this screen, that is new channel, right? So enter the name of the channel, enter some description related with your channel, and you can select the fields. Okay, so here I have invoked just 2 fields, field 1 and field 2, and you can see the namings, the temperature and humidity. You can change the name. Okay, select the fields in which you are inserting or storing the data. Any doubt up to this point?
No, sir.
Shall we move forward then?
Yeah.
Now next part. Next part is related with the security. So how can we send or receive the secure data? So we have API keys. Now, after creating your own channel, go to the API keys tab. Now please go to this tab, API keys tab. Is it visible to you all? Please let me know if it is visible or not to you.
Yes, sir, it's visible.
It is visible. Okay. So have you visited this tab? Everyone?
Yes, sir.
Can you see this? Write API and read API.
Yes, sir.
So what this write API and read API key is all about, let's have some detail about it. When you are sending the data from your hardware to the ThingSpeak cloud, at that time you require this key to be put inside your code. And when you're retrieving the data back from the cloud to your hardware, then you require this read API keys, okay, to be put it inside your software. This key is unique for every channel so that the security will be maintained and the hackers cannot play with our data, okay. Now copy and paste this somewhere, so you will need it later on. Also one more thing is there, that is the channel ID, okay. This channel ID is also unique, and this also be used for manipulating with your hardware data with the ThingSpeak cloud. So again, copy this somewhere, so you will require it later on. Now ThingSpeak also has some API requests, like writing a channel feed, reading a channel feed, reading a particular field, and looking at the status updates of the channel. So only you have to paste this link into your browser and work on it, just like we have seen before that sir have taken this link, put it in the browser, and he was creating the own data even if the hardware wasn't there with him, okay.
Excuse
so
me, sir.
just like so you can also do this.
Excuse me, sir.
Yes.
Can you please show the channel description slide?
This one. Okay, this one.
Sir, previous. Yes, sir. Yes, sir,
Okay.
this one.
Sir, there are some questions in the chat box. Can you please refer?
After the presentation, we will come on to the questions. Is it related to this slide or what?
Yes, sir. Yes.
Question. What are the? That is optional. That is optional. Labels can be optional. Labels are absolutely optional, means it is related to the field, okay. So you can give any name to the field. For example, temperature, pressure.
Okay, sir. Sure. Got it.
Okay. So they have given some API request as well. So using this these links, you can create your own data even if you don't have the hardware with you. So you can try out like writing a specific data to a channel, okay, reading a specific data from a channel, reading a specific data from a specific channel feed, or looking at the whole status of the channel, okay. Then sharing. Now the sharing has three parts: keeping your own channel private so that nobody can access your data, share it with everyone, so without any API key anyone can take out the data using a CSV format or anything like that. Or you can share the channel to view only with the with some users, just like in our Facebook. If we upload the photo, so at that time we have the choice, keep whether you want to show it to everyone, show it to public, or only to your friends. So similarly, they have given the accessibility option over here, so you can keep the channel private if you have any confidential information with you of your organization, or you can share it with everyone, or you can share it with only some of the specified users. So this was about sharing, okay. Now the next part deals with the analytics. So it is not only about sending and receiving data from the system or to the system. They have given some analysis point also, because ThingSpeak ultimately has created by your MathWorks. So that's why. Okay. So you can do the analysis and visualization as well. Just like this, you can tabulate your own data. So this was about IoT Cloud. Now let's move forward to the demonstration. So our first demonstration deals with a very interesting topic, that is a parking system. Okay, so we have designed an empty or filled parking system slot alert. So as we know, the parking a vehicle is a big concern in big cities. So it is essential to know the nearest parking station where we can park our vehicle. Hence, using this problem, we have developed a solution using IoT named as IoT based parking system. So let's realize the demo of this. So let me switch my control to Aditi Kulkarni. So I request
Can you please repeat API keys?
About API keys.
Yeah.
Just a minute. So after creating your channel, visit to API keys tab. Do you have this sort of a dashboard on your browser? Gaurav sir, do you have this type of a dashboard on your browser? So go to
Yes,
API
sir.
keys.
Yes.
त्यांचं नाव वेगळं असेल. So go to API keys. And here you can see two types of API keys are there, write API key and read API key. So write API key means whenever you are sending the data from your hardware to the channel or to the ThinkSpeak, you require this key to be put it inside your software. Okay, and read API key is absolutely opposite to it, which means if you want to retrieve the data from the ThinkSpeak to your hardware, at that time you require this read API key. Getting my point?
Yes, sir. Got it.
Any other doubt?
No, sir.
So shall we move to the demonstration part?
Sure, sir.
Okay. Sir, I request you to hand over the control to Aditi Kulkarni ma'am.
Okay, sir.
Wait, we will see the code as well. Gaurav sir, please wait. So that
Okay, sir.
I can give the coding part also.
Okay.
Okay, so you have to write this to inside your ESP32 board. Okay. Can you see? Now, can you see this screen?
Yes.
Yes, sir.
Let me zoom it a little bit. Yeah, okay. Now, as we know that Arduino IDE has a facility of doing the C programming using libraries. So the difficult part is being solved by the libraries. So that's why we require two libraries. First is #include thingspeak.h. So that we can manipulate all the functions related to the ThinkSpeak using this library, like sending the data or receiving the data. Then we have Wi-Fi.h. In the starting of the lecture, sir has said that our ESP32 connects with the local router and ultimately to the cloud. So that's why we require this Wi-Fi.h to connect our ESP32 board with the router. Okay, that is Wi-Fi. Then we require two parameters. One is SSID and second is a password. So that SSID is the name of your Wi-Fi and password is a secret key of your Wi-Fi or a password of your Wi-Fi. So here you can see Android AP is the name of my hotspot and this is my password. Okay. After that, we have declared an object for dealing with the Wi-Fi. That is Wi-Fi client is a class and client is an object. Then again, we have taken one variable for storing the value of the temperature. Then channel number and API key is the important part in this code. So my channel number is the channel number in which we are going to do the computations. So the name of the channel number, and here because we are sending our data to the cloud, so that's why write API key. Okay, so the write API key of my channel I have pasted over here. Okay, you can paste it your own. Then we have used an ultrasonic sensor, so that using an ultrasonic sensor, we have created a parking system to check whether a parking slot is full or not. So that's why we have taken for 2 pins. First is a trigger pin and second is an echo pin. So in ultrasonic sensor, we have 2 pins for sending the ultrasound into the nature and retrieving it back. So trigger pin is sending the ultrasound in the nature, and echo is catching that into the microcontroller. So trigger is connected to number 4 and echo is connected to number 5. So, and then one parking status flag is there. Okay, so we will use it in our code. Then for calculating the duration and the distance between the object, that is our car, and the sensor module, we have these 2 variables. Then when we are dealing with the microcontroller, so every time our code supposed to get transmitted into the microcontroller using serial communication. So we have initialized the serial communication inside the void setup. Void setup is used for one-time running of your instructions. So these instructions are only for initialization. That's why we have put it inside the void setup. So serial.begin at the baud rate of 9600. After that, we have configured our pins. So because we are sending the ultrasound to the nature, so that's why this pin is set as an output. So this is nothing but a Gpio pin, which is configured as output. And echo, we are receiving the reflected wave back. That's why it is input. Then we have initialized the Wi-Fi using Wi-Fi.begin command. And inside that we have passed 2 parameters, that is SSID and the password. And then using this while loop, we have checked whether our Wi-Fi is connected to the hotspot or not. Okay, if it is connected, so we have printed this local IP, and then we have initialized the ThingSpeak communication using ThingSpeak.begin, and we have passed the parameter, that is client. Any doubt up to this? Shall we move forward?
Yes, sir.
Okay. Then inside the void loop, we supposed to write the commands which we want to run again and again, just like our while one. So this is a function known as distance test. So this will calculate the distance from the car to the system. Okay. So using the principle of ultrasonic waves. And then we have checked if the distance is less than 40. So this is 40 centimeter. Okay, turn on the flag of park status 1 and send the value of this flag to the ThingSpeak using 2 commands, ThingSpeak.setField and ThingSpeak.writeField. Now, before writing the status, we require to set the field, which means we have to tell the controller and ultimately to the ThingSpeak cloud at which field we are sending the data to. So that's why ThingSpeak.setField 2 is nothing but a number of field and our variable, that is our parking flag. So setField will initialize the data to field number 2 and whatever data we have, and then ThingSpeak.writeField, my channel number, again the field number, again the variable we want to pass, or again the data we want to pass, and last but not the least, the API key. Okay, so using this 4 parameter, it will write the data to field number 2. So you can change to any number, that is 1, 2, 3, 4, depending on your field. So this concludes our code. And what is the conclusion? We are sending the data of parking system number 2 to the field number 2 of the channel. So any doubt up to this?
No, sir.
Okay, fine. Now let me share you one more screen which will display the parking slots. Can you see the screen? Akshat sir and Gaurav sir?
Yes, sir.
Yes, sir.
So these are 4 parking locations. Okay. Now let me come to the main demonstration part. Gaurav sir, please share your control to Aditi Kulkarni ma'am.
Sir, she is already a co-host.
Okay, fine, fine.
नाही शेअरिंग दिसत नाही इकडे दिसतात इकडचं इकडे दिसेल Am I audible to everyone?
Yes.
Okay.
Yes.
Focus माझ्यावर ठेवा. So now we have 4 locations. You can see 1, 2, number 3, and number 4. So we have 4 parking locations placed at 4 different places. Now our next thing is to check if a car comes in front of it, so that location will be full. Okay. Now we have simulated this using the ThingSpeak cloud, and we have sent the data of these 4 locations to the ThingSpeak cloud. Now here you can see location 1, location 2, location 3, and location 4. Okay. So currently there is no cars present on these 4 locations. So these locations are empty. Now look, now this location is full.
The car is closed.
So the car is placed over here. So now the location 1 will so the location 1 is full now.
After 15 seconds indication.
After 15 seconds the indication will come. Parking location number 4 on the
friends. Now we can see this delay indication happens only because we are using free service. So with a delay, you can see that indication has gone on.
Now location 4 is on now. Let's see one.
So this is how when cars come to the parking becomes full and we have indication on the screen. So now let's move on to sending email or Twitter. Control is not Gaurav sir, please give the control to Cognifront.
Okay, sir. Wait a minute.
Google Assistant. Google Assistant.
Cognifront is the co-host now.
Our next demonstration is based on sending the email from the ThinkSpeak cloud to the owner of the hello. Am I audible?
Yes, sir, you're audible.
Okay. So our next practical deals with the email. So we're going to send an email from ThinkSpeak to the owner of the company. Okay. So as we know, just a minute, let me share the screen so that you will get to know more about it. Browser. Is the screen visible?
No, sir.
Can you see the coding
We
part?
can only see the can.
Okay. Can you see the screen? ThinkSpeak.
Yes, sir, the screen is visible.
Okay. So we're going to study how to read the channel and trigger an email. Okay. So in this we have a MATLAB code. So because this ThinkSpeak is created by MathWorks, so they have given some MATLAB related things like MATLAB analysis, MATLAB visualizations and all. So using MATLAB, we will going to send an email. For that, we require channel ID again, then alert API key. So this is a special API key. You won't get this API key in the channel. So you have to go to my profile. From here, you have to go to my profile. And here is the alert API key. Always remember that alert API key starts with TAK. Okay, so this is your alert API key. So you have to copy this alert API key and paste it over here. Okay, then alert URL. Again, this is a unique URL, https://api-thinkSpeak.com/alerts/send. Okay, after that, this function deals with the web options and all. Then alert subject. So in your email, what subject you want. Then using ThinkSpeak read, you can read your field. Okay, and store the data inside this variable. So if the data, if the received value is less than this calculated value, so alert body will be I need water. else if it is greater than this value, it will show that no water is needed. So this is just an example of a humidity of a gardening system in which the humidity is being measured. Okay, so they have sent the humidity value to the ThingSpeak cloud. Okay, and what they are doing, they are just measuring whether it is less than 30 or greater than 30 using this function. Okay, and if it is less than the threshold, so obviously the gardening related hardware will send the SMS to the owner that I need water, else no water is needed. Okay, and then we will send the SMS using this, send the email using this function, where write alert URL, alert body, subject, and options. Okay. Now let's run this. Now remember, always remember, hello, am I audible?
Yes, sir, you're audible.
Now always remember, whenever you are creating your own ThingSpeak channel, at that time you are giving your own email to it. Okay, so that's why this email will come into the owner of the ThingSpeak channel. Okay, so I'm showing you the demo. You can perform it on your own ThingSpeak channels. Okay, so that you will get to know how this email comes to your own email ID. So this will come to my email ID right now. Okay, this will go to the patient monitoring. Now let's just create some data. Just like you all, suppose I also don't have any hardware, but I want to create a data for simulating the email practical. So the condition was to check if the humidity is greater than 30. So let's enter some value. Okay. Here we go. We have 35 value. Okay. Now inside the email, let's check whether we have received an email or not. Yeah, you can see plant soil information. I need water. Okay, so the condition is getting satisfied. Too many tabs are open. That's why. Okay, so related to these conditions, we have got the email, that is, if it is less than the dry value, so it is less than the dry value, that is 30. Sorry, that is this dry value, and that's why we are getting the email as I need water. Getting everyone? Am I audible to you all? Gaurav sir?
Yes, sir.
So now I request Dr. Tiwari sir to continue, please.
It was nice talking to you and sharing some demonstration, but as we know, there are certain limitations of giving hands-on in a very short period of time. 2 hours is not enough for that, but I hope all of you could get some central idea about connecting devices to the ThingSpeak. Here we have used ESP32 microcontroller board to connect to the ThinkSpeak and thereby send the sensors data to the ThinkSpeak and do some kind of analysis, and from there send the commands for actuating certain actuators. There are a few more demonstrations to be given, but I think first we will go through question answer session and then decide whether to get the further demo or not. So Gaurav sir and all of other participants, now session is open for question and answer.
So Rishabh Sharma has requested if you can share the PPT after this session.
Yes, surely. I have already sent the presentation to Gaurav sir. I hope he will, forward to all the participants. Okay. Any other question?
Yes, sir. Ankit Soni asks, sir,
Okay.
what is the estimated cost for applications like car parking for mass production?
For mass production, I think cost should be less than rupees, say 950. So with a small product, which will actually find out whether the parking is full or empty, 950 rupees is more than enough for mass production, of course. For single device, cost are 2,000.
Those answers.
Next question.
So I think everyone has understood the presentation.
So thanks a lot. And I also thank Mr. Swaraj Tade, my colleague, and Mrs. Sushma Patil and Aditi Kulkarni. They have helped arrange this demonstration. So thank you very much.
Thank you, sir, for such an instructive and informative session. Thank you all. Thank you all for your questions. The link of the feedback form is floated in the chat box. Kindly fill the feedback form before leaving the session. The next session will be a guest lecture with IoT from 3 p.m. onwards. The link for the session is the same and has already been shared in the chat box. Hope to see you all there. Thank you, everyone, and have a great day ahead.
Thank you.
Thank you so much.